All right, we are now recording. Let's go from current slide, and before we get going on that, we don't have video yet anyway. Let me go over a couple of announcements. This one I just got in the mail yesterday. Why so late coming? But this is an announcement that's happening today. But it's on the Birmingham, barely on the West campus. It's right almost at the boundary of East and West campus in Birmingham. Boston State Community College has a ribbon cutting and official opening for the new Academic Success Center. I don't know if y'all have seen it being built there on Wilson Road. It's where the old, I think it was Winona Elementary School was. I believe that's the school that it replaced. They built new schools, I guess deeded over the land to us, and they have now built this. Very impressive looking structure. See pictures of it here too. And that's the ribbon cutting and official opening. And there's actually two things. There's also the second residence hall, a little bit smaller than the first one right next door to it though. And that's being dedicated today. All right. Here are the homonyms. Okay. And here's TK. If I can find you. There you are. Does anyone else come in since the call roll? Oops. Then here's Patel. Okay. So this is happening today. 2 ribbon cutting and official openings today. Unfortunately at 10 o'clock this morning. So we get out of class here at 9:45. If you want to make this, you'll need to book it over there pretty quickly for these 2 openings, the Student Success Center and the second residence hall. These are on the Birmingham West campus. Well, okay, get this correct. The Academic Success Center is on the, okay, be on this here.
Kim.
I'm sorry. I just can't find you. PR, right? Huh? Yeah, Kelly, I'm sorry. I thought you said, okay, good deal. Anyone else come in since I called roll? So to get this correct, the Academic Success Center is just on West Campus. It's across Wilson Road, and the Residence Hall is just across Wilson Road on the East Campus. And there's Dion. Okay, so that's, I don't know which order. My guess is the Academic Success Center will be at 10, and then they'll follow that by going across the road to the Residence Hall. Okay, now, if just the excitement of seeing a new building wasn't enough, refreshments and guided tours of the building will be available immediately following the program. And if you need information, there's a phone number here too, so for those who are interested. Now, the second announcement is one of those kind of good news, bad news situations. Sorry about this, but it's reality. The good news is next week is spring break week. Okay? The bad news is we won't be meeting. Sorry. You'll have to get over it, but we won't have class either day next week. But if you still want to be here, knock yourself out, okay? You can listen to a YouTube video just to see what you've been missing. Okay. All right. Any questions about anything? Okay. Then let's hit where we left off before. We were talking about the division algorithm. I think we got this covered last time. Any questions on this? Actually, 2 ways to write this. This is one. F of x is equal to the dividend is equal to the divisor times the quotient plus the remainder. It's how we always check division. Multiply the divisor by the quotient and add the remainder. Okay, so this is one way to write it. The other way is to divide everything by d of x. And then f of x divided by d of x, that's what you're doing. You're dividing the dividend by the divisor. That leaves you the quotient, and then you have the remainder over the divisor, just like we used to do it. Now, if the remainder happens to be 0, that means two things. One way, d of x divides evenly into f of x. But another way of saying that is d of x is a factor of f of x. And q of x is a factor. If you have a remainder, they're not factors. Okay? So, that's only if the remainder is 0. Oh, you've already been here once. Okay. So, moving to the bottom of the page, and this is what I was just describing, the second way of expressing that, f of x is equal, divided by d of x is equal to your quotient plus remainder over divisor. Now that's what, okay. All right, h of x here. There you are. All right. Any others come in since I called roll? All right. Now, so either of these can be good expressions of the division algorithm. In this algorithm, the rational expression f of x over d of x, in order for you to do the division, f of x has to be a greater or equal degree to the divisor. Greater or equal, okay? F of x divided by d of x, and we call that improper. Just like 7/3 is an improper fraction, 2 1/3 would be the mixed number. 2/3 would be a proper fraction, okay? So with fractional form, if the numerator is greater than the denominator, it's called improper. If it's less, greater than or equal to the denominator, it's called improper. If its numerator is less than the denominator, it's called proper. Same thing here, except we're talking about degree. If the degree of the numerator is greater than or equal to the degree of the denominator, it's called improper. Okay? Now, in order to do the division, it's got to be improper. Okay? Because you can't divide d into f if f has a lower degree than d. You already got your fractional form. On the other hand, okay, the rational expression r of x divided by d of x must be proper. The degree of the remainder must be less than, not less than or equal to, less than the degree of the divisor. If it's not, keep dividing, okay? Keep dividing. Keep the process going until your remainder is a lower degree than your divisor, okay? Same thing with a division and long division of numbers. If you came up with a remainder greater than the divisor, you go back and do it in again, because we'll go at least one more time into the number you were dividing. Okay? So the remainder rational expression must be proper. The first one, the dividend divided by divisor, must be improper. Otherwise, there's nothing to divide. All right. Now, couple of warnings here. Before you apply the division algorithm, follow these steps. Okay? Write the dividend and the divisor in descending powers of the variable, what we usually call standard form. Write them in descending order, both the dividend and the divisor. But the second thing, insert placeholders with 0 coefficients for missing powers of the variable. So if you had a dividend that started with x cubed and the next term was x, put a 0x squared in there. You need it to hold the place so you can do the division, the long division properly. Okay? And it's not as essential, but it's a good idea to do it with a divisor as well. Keeps you from making maybe some mistakes in lining things up. Okay? Now, they're skipping examples 2 and 3. So let's go back and see if we can find some white space to put these on. There, it looks like our white space. Okay. So let's do example 3. Divide, let me get my pen set up. Okay. Divide x cubed, and I'm going to change something here, my location. Okay. I'm going to put the problem up here. Okay. Divide x cubed minus 1 by x minus 1. Okay? Divide x cubed minus 1 by x minus 1. Okay? Now, I want you to tell me how to set that up. I will begin it for you by putting the house there. Okay? You tell me to put what to put outside the house, what to put inside the house. Second? 1. Outside? Excellent. Okay. And what do we put inside the house? X cubed. Aha! Plus 0 what? X squared. Plus 0x minus 1. That's what goes inside the house. Remember, you have to, okay, number 1, these are already in descending orders of the power. That was fine. But we're missing terms here. No missing terms there, so we didn't have to worry about that. But for every power that you're missing in the either the divisor or the dividend, you have to insert a 0 with the proper power for x. Perfect. Okay? Now what do we do? Okay, first term in the first term. X will go into x cubed how many times? X squared terms. Excellent. Okay, then you do what? Multiply. X squared times x is? X cubed. Perfect. X cubed, x squared times a minus 1 is a minus x squared. Do you see why you need the 0x squared in there? If you didn't have it there, there's no place to put that to line it up. Okay? Then what do we do? Second? Okay. You subtract by changing signs and adding. So we'll make that a minus and that a plus. Okay, those add to 0. What you get? X squared. Okay, and then do what? Bring down what? Nothing. Okay, yeah. Plus 0x, which is nothing, but we still bring it down. And what do we do with that then? Second? Plus x. Okay, x into x squared will go plus x times. Okay? Now the book shifts their quotient down. It doesn't matter where you put it. I like to put it there, but it doesn't matter. Okay, x times x is x squared and negative x. And then we do what? Change signs and add, minus the plus. And what does that give us? Those add to 0. These go to x minus 1. And guess what? That goes into that plus 1 times. Okay. You have to go because, see, every time you really should stop yourself because, you see, this could have been a remainder. But no, it wasn't a remainder because its degree is greater than the divisor. So keep going. When you got here, that could be a remainder, except the degree is equal to the divisor. The remainder degree has to be less than the divisor. So we divide again, and that gave us plus 1. And then what do we do with that? 1 times x is x. 1 times minus 1 is minus 1. Guess what, team? It goes in there exactly. Okay? Remainder of 0. What does that tell us? This is a factor of that, but also this is a factor of that. But we knew that, didn't we? Oh, yeah. If you go back and think, didn't we learn how to factor x cubed minus 1, difference of 2 perfect cubes? Oh, yeah. What was that? cube root of the first one, x, same sign, minus the cube root of the next one, 1. And then what was the second factor? Okay, you take the first one, square it, x squared, minus the product. This is a minus 1. The product is minus 1. Opposite of that is plus 1. Minus x. Opposite of that is plus x. And then you square the last plus 1. And sure enough, that's exactly what we got. So we could have done that by factoring, but we needed to practice doing long division with missing terms. Does that make sense? All right, good deal. And they got the right answer too. Good for them. Now, I don't mind you just leaving the, excuse me. Y'all awake yet? Okay. I didn't believe you. Okay, never mind. Okay. I don't mind you just leaving the answer like that. It's pretty obvious what the answer is. But they quite often will then rewrite it as a division algorithm thing. Either this thing over that thing is equal to this thing plus 0, because the remainder is 0. Or the other way is this thing right here. This thing is equal to this times that, okay, with a 0 remainder. So either way you want to write the answers, probably in the back of the book it's going to be one of those two ways, okay? But if you know what the answer is, fine. And by the way, for every example, there is a checkpoint. I'd highly recommend you do the checkpoints shortly after you leave class, as soon as you can. All right, example 3 is also not on the PowerPoint. So let's erase all that. And it looks like Tara. Yes, it is. Okay. Very good. Anyone else come in while I wasn't paying attention? Okay. So, example 3. Now, the thing about example 3, even though it's not on the PowerPoint, it is at larsonprecalculus.com, and you can go there and see an interactive version of this type of an example. So here's what we're asked, and again I'm going to use it up here. Divide, what in the world are you doing? Okay. All right. Divide minus 5x squared minus 2 plus 3x plus 2x to the fourth plus 4x cubed. Does this go on forever? Okay. By, okay, then we'll pick up our by down here. Whoa. Instead of this, we'll have 2x minus 3 plus x squared. Okay. Now, by the way, I think the last time said check the result, and we should have, but we didn't. How you check those is multiply the quotient by the divisor, and you got it. Okay. We sort of did check it by saying, hey, this is how it factored anyway. So that was kind of a check, but it wasn't what they meant. All right. Again, I'll start the problem by building the house for you. You tell me what goes in and outside the house. Oh, my goodness. Okay. Yes, you see that? Out of order. Okay. Bang, out of order. Okay, now. So start with the largest term, 2x to the fourth, plus 4x cubed, minus 5x squared, plus 3x, minus 2. I think we got them all, didn't we? Okay. And that's divided by x squared plus 2x minus 3. All right. I'm going to have to write small, I'm afraid, because this may take... No, actually, it won't take as long as you think, because this is a squared into a fourth, so it can't be more than 3 steps. So it's about the same as before. All right. How do we begin? Okay. X squared will go into 2x to the fourth, 2. And here's how I do this in case any of you are wondering. I take the coefficient of this, 1, divide it in the coefficient of that, 2, 1 will go into 2 twice. Then do the variable part, x squared into x fourth. We'll go how many times? X squared times, right? And then what? Multiply. 2x squared times x squared is 2x to the fourth. It better be. That's why we did it. Okay. Next. Plus 4x cubed. Excellent. Oh, my goodness. Minus 6x squared. And what? And that's it. Okay. Now, what do we do now? Change signs and add, which is subtracting, but it's okay. So that becomes a minus, that becomes a plus, and the other becomes a minus, and I have to erase the vertical bar to make it a minus. Okay. And when you add, what in the world happens here? 2x to the fourth, add to 0. 4x cubes, add to 0. And what does this add to? X squared. And then you do what? Bring down a plus 3x. And since that has 3 terms, we'll bring down the third term here. See, we wiped out 2 rather than 1, so we actually bring down both of those terms. Okay? So this is actually shorter than the last problem. Okay? So, what next? X squared will go into x squared how many times? Plus 1 times. And then you do what? Multiply. And that gives you x squared plus 2x minus 3. And then you do what? Change signs and add. So again, that's going to be a minus, a plus, and the next one's going to be a minus. So wipe the, ooh, it didn't pick up. Okay. All right. Hold on. Hold on. Carlos here. Couldn't find your name. Okay. Anyone else come in since I called roll? Okay. So we've changed sign. Let's add now. X squared. Add to 0. Oh, I forgot to take off my eraser. Okay. So I really did wipe them out. Okay, they add to 0. Next, x plus 1. Okay? Yes?
So, I know you, somebody talked about the little tree.
Right.
You know, right, but it's not able to do this particular problem. They said your highest degree in the problem is going to deceive. So whatever your answer is going to be like minus that.
Okay.
Right?
Okay.
Why is it like that for this one?
Okay, it is. It's not that this answer is less than this one, it's that this answer is less than that one. That's what decreases. The power always decreases there, and it decreases by this amount. You subtract here, because with exponents you subtract, 4 minus 2 is 2. So it has to subtract. Okay? But talking of degrees, are we through?
No.
Why not? Because the remainder is a lesser degree than your divisor, you are through.
Right.
If that was equal, like here they were equal, keep dividing, okay? But when this comes out less than this degree, you're done, okay? If there's anything else out there, bring it down to that part of the remainder. We've got it all here, so we are done. So, there's 2 ways to write this answer, okay? You can first say, let's do this thing divided by that thing is equal to this thing plus that. That's one way. Or, and you write that as a fractional form. This over that is equal to this plus this over that. Okay. Or the other way is this thing is equal to the product of these two plus that. Okay. And that's what they mean by checking the results. Do y'all want to do that? Okay, I don't either. It's easy to do, but it just takes a lot of steps. So, but you can check the result. And there's a checkpoint right under that, so I highly recommend you do that. Now, let me point a couple of things out to you. We've been doing it every time. We really weren't using the X's very much except just to keep up with them, right? Okay? And because these always cancel, that always had. That's why we did it. That's why we divided that into that, so this would go out completely, and that would go out completely. So we lost those. Now this is just happenstance. We lost that one as well. Okay? The degree's always going down, like you pointed out. This degree is always going down. By how much? By the degree of this one. Okay? So that's it. Now, we were always multiplying and then subtracting, which is the same as changing signs and adding. Okay? So, keep those things in mind as we introduce the next concept, which is synthetic division. This problem could not be done by synthetic division at all. Don't even try. And I'll tell you why in just a second. Here's, oh wait. Oh, this was the one from the last one that we, did we do that? No, this was example 1. So we did that last time. I just had to go back there to get some white space. Okay. Now we get to synthetic division. You know, it's not real division, it's synthetic. No, I'm just kidding. Okay. There is a nice shortcut. That's what makes it nice. A shortcut for long division of polynomials by divisors of this form. That's why the last one wouldn't work. It had an x squared in it. This doesn't. Here's what I say about the divisor. The coefficient has to be a 1. The exponent has to be a 1. If you have a coefficient here, don't try synthetic division. If you have an exponent there, don't try synthetic division, okay? And the last one we had, I think both of those, okay, it was a 2x squared, wasn't it? No, maybe not, the earlier problem. So that shortcut is called synthetic division, but it only works when your divisor looks like that. Now, it can have a plus sign in it. What would the k be then if that was a plus k? K would be a negative number, okay? And with a minus k is a positive number, okay? The pattern for synthetic division of a cubic polynomial, why they chose cubic, I'm not sure, but they did. Maximum exponent of 3. Synthetic division of a cubic polynomial is summarized below, and the pattern for higher degree polynomials is very similar, okay? Now, they love starting with letters. I like numbers better, but they started with letters. So, and I don't quite set mine up this way. It's very similar, okay? So, to divide ax cubed plus bx squared plus cx plus d, they've got all the terms there, descending orders of power, by x minus k. Remember, it had to be that form. Here's the pattern. What you put outside the house, let's forget about our variables for right now. We're going to come back and put them back in later, but right now we're going to take them out, okay? So we're not even going to mess with the x here, and we're going to change the sign of the k. Why? Well, remember before we were always having to change signs and add, so we're going to change sign of that right now, and then all we're going to do is add. So there's no more changing the sign. Just change the sign of the k to begin with and put it outside the house. That's all that goes outside the house. What goes inside the house, again, forget about the variable, just put the coefficients, A, B, C, and D. Okay? Now, my statement then is to skip a line, draw a line. I'll never see that printed. Skip a line, draw a line, a horizontal line here. And you bring down that first coefficient, A. That's not going to change because remember, the coefficient of this is 1, the exponent is 1, so that A is going to come down undisturbed because it's not going to change a thing. The variable will change, but we don't even have the variables in here. So what do we do then? We multiply K times A, that gives us KA. Then you add it to B. These are just numbers, we just don't know what they are. Add to that, that fills in this circle. Multiply again, put it here. Add, put it there. Multiply again, put it there. Add, and that becomes the remainder. So I do mine a little differently. Now what do we have here? The a is the first coefficient because if you divide x into ax cubed, you're going to get ax squared, okay? You know that. So there's the a. You just put in the variables at 1 degree less than they were here because you divided by x. So it dropped them 1 degree. The coefficients, whatever you wind up here. Now, this isn't going to be the b anymore. That will always be the a as long as that coefficient is 1 and power is 1, okay? So this will be ax squared plus whatever this is, x, plus whatever that is, constant, and then there's your remainder, okay? So the vertical pattern here is your adding, and the diagonal pattern is your multiplying. This times this, this times this, this times this. You're adding going down, okay? Now, to me, it's much easier to do with numbers, so let's do it with numbers. Okay. Well, wait a minute. They do have this slide in here. This algorithm for synthetic division works only for divisors. Have we said this before? Of the form x minus k. And my rule is coefficient of 1, exponent of 1. Okay? And what goes outside the house? Yes, the opposite of this sign, k. Okay? Whatever the opposite is. That would be a plus k. And this probably, k may be negative, that's okay. But whatever the opposite of that is. Okay? Now, remembering that x plus k is x minus a minus k. So if that was a plus here, you put a minus k outside the house. Okay. So just keep that in mind. Okay. So let's do this one. Use synthetic division to divide x to the fourth minus 10x squared minus 2x plus 4 by x plus 3. First thing you ask yourself, is this a candidate? They say use synthetic division. They may be trying to draw you out and lead you down a bad path. Is that a candidate? Coefficient of 1, exponent of 1, yes it is. Perfectly fine. So here's how I draw my house. I do it like that. What goes outside the house or inside the angle there? Yeah. What goes right there? Say again? Negative 3 is always the opposite sign of this. So it's minus 3. Now, I'm going to give you a reason for that that may not make sense now, but hopefully it'll make sense later. If indeed this was a factor, and you had set that equal to 0, and you said x plus 3 is equal to 0, what would x be? A minus 3. That's what goes out there. Okay? So it's always the opposite sign of whatever that is. Okay? What goes inside the house? 1. Oh, very good. Notice, again, it's division, isn't it? If you're missing a power, put in a 0 coefficient. Next, negative 10, negative 2, and 4. Here's my little trick here. And I should have done it with the other one, but I forgot to say it. Stretch or a question? Stretch, okay, all right. Okay. I look at my maximum degree. What is that? 4. How many terms do we have here? 5. Always one more term than that. If you don't have it, find the missing term because it's in there somewhere. And that, by the way, is a negative 10. That's one of the ugliest negative 10s I've ever seen in my life, okay? So let's see if we can clean that up a little bit. No promises. A little bit better, okay? Then my next step is skip a line, draw a line, okay? Now you do what? Bring down the 1. Then you multiply, and that gives you. And then you add, and you get negative 3. And then you get 9. Then you negative 1, add and get negative 1. Then you multiply and get a positive 3. Then you add and get a 1. Then you get a, say, minus 3. And then you add and you get a 1. Break that one off, okay? I separate this way. That's the divisor. I separate that way. That's my quotient. Okay? That's how I do it. Okay. Now I go back in and fill in the variables. We took the variables out to do this, put them back in now. What's your answer? X to the third power, always one less because this was x to the first power, okay? Minus 3 what? X squared minus x plus 1 with a remainder of, and let's just write it this way, okay, plus 1 over x plus 3. Remember, 1 over your divisor, or remainder over your divisor. There's your answer. Okay? Now, written in that form, this would be preceded by x to the fourth, blah, 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 divided by x plus 3. Is equal to the dividend divided by divisor is equal to quotient. Big old quotient there, plus remainder over divisor. See how it works? Any questions on that? Does that make sense? All right. Let's clear the screen and see if Hamina's on the roll still. Let's see. Oh, she is. Okay, good. Yay. Okay. So I was just about to clear the screen. We're doing example 4 at bottom of page 139. In chapter 2, polynomials and rational functions, 2.3 polynomials and synthetic division. We've just done our first synthetic division problem. So you can go to the YouTube video and catch up on it, or watch it right here and see how they do it. Okay, set up the array, that's what they call it, as follows. Note that the 0 is included for the missing x cubed term. Okay, so what's outside the house is the minus 3. Always the opposite of that. Okay, always the opposite of that. You've dropped your variables all together. So outside the house is the minus 3. Inside of the coefficients, because we dropped the variables, 1, 0 for the x cubed term, minus 10 for the x squared term, minus 2 for the x term, and plus 4 for the constant term. Okay, and my little rule, saying it again, is look at the maximum power 4. You should have one more term here. 1, 2, 3, 4, 5. Got it. Okay. Then we bring down the 1. Whatever that was there, bring it down here. Okay? So we'll do that. They pointed us that way. And then you multiply. Minus 3 times 1 is minus 3. Then you add, and that becomes negative 3. Then you multiply, and that becomes positive 9. Then you negative 1. Then you positive 3. And then you 1. And then you negative 3. And then add, and you get 1. I like to separate that out so you don't confuse it with the quotient. That's the remainder. This represents the quotient. Okay? Well, what is that quotient? Now we go put the x's back in. And because we were dividing by an x to the first power, that means you reduce the quotient by 1 power from what you had to start with. So this becomes x cubed. Okay, so it's 1x cubed, or just x cubed, minus 3x squared. You just go downhill from here. Minus x plus 1 with a remainder. You can put that plus 1 over whatever your divisor was, x plus 3. Okay. Same thing we got. Now they're going to fill in the blanks, so let's watch them do it. Okay? The divisor, since you were dividing by x plus 3, put the opposite of this number here. The reason we did before, we were always having to change signs and add. This is change sign of our divisor, and that way we don't have to change signs. We've already changed it. You just add. Okay? You put your coefficients here, being sure you account for any missing coefficient with a 0, placeholder. Okay? Get all the others in place. check them, make sure you got the right number. We do. And then bring down, oh, skip a line, draw a line. That's the step they never say, but they should, okay? And then bring down the 1. Whoa, he really wrote it down there, okay. Okay, and then you, once you do that, multiply. Minus 3 times 1 is a minus 3. Then add, 0 plus minus 3 is minus 3. Multiply, minus 3 times minus 3 is plus 9. Add minus 10 plus 9 is a minus 1. Multiply again, minus 3 times minus 1 is plus 3. Add minus 2 plus 3 is 1. Multiply again, negative 3 times 1 is negative 3. Add your final time, and you get 4 minus 3 is 1. That's your remainder, okay? Now, interpret, okay, this quotient down here, it's just numbers, to be coefficients of 1 degree less than your dividend was. So 1x cubed minus 3x squared minus 1x plus 1. Got it. Make sense? And then remainder of 1, so that would be plus 1 over x plus 3. So I think they're going to write that this way, and they do. It's dividend divided by divisor is equal to your quotient, big old long hairy quotient there, okay, plus remainder over dividend, okay, plus 1 over x plus 3. Now, if you prefer long division, knock yourself out. It still works. This, to me, is so much easier, okay? Only works if coefficient 1, exponent 1. Only. Okay, make sense? All right. Now, wait a minute. Why are we doing division anyway? Why do we jump to this? Well, remember what sort of this whole section was about? Here's Q. I always think of James Bond, but I don't know why. Okay, y'all don't know James Bond. Never mind. Okay. We can learn some things from division, especially that synthetic division if you can use it. Okay? And here are 2 theorems that are going to help us learn things. The remainder theorem and the factor theorem. Let's start with the remainder theorem. Remainder obtained by synthetic division process has an important interpretation. It's described here. If a polynomial, f of x, is divided by x minus k, that's exactly what we did for synthetic division, coefficient 1, exponent 1, then the remainder is what? Remainder is f of k? Whatever this thing was, remember I said this is the same as x equal k? Okay? Plug that in here, evaluate. Anyway, I'm not sure I'm going to buy that. Let's go back and see if that works. Okay? If that's true, okay, then what you're telling me is that f of, what's your k here? Negative 3 should be 1. Are you kidding me? Well, let's see if it is. Okay? This would be negative 3 to the 4th power. Anyone know what that is? Ooh, that hurts. 81. You're absolutely right. 81. Positive 81 because that's an even power, so the minus, 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 minus becomes a plus. Minus, what's negative 3 squared? 9. So that's minus 90. Yeah, big numbers, okay? Minus 2 times negative 3 would be plus 6, and then a plus 4, okay? Hey, all that can't come up to be just 1, can it? Let's see, let's add our positives together. 81 plus 6 is 87. Oh, that's a 4, I can't read. Okay, plus 4. All right. Yuck. Okay, now we can do it. 81 plus 10 is 91 minus 90? It's your remainder. It's what? Oh, is it just this case?
No.
Every case. So guess what? Which was easier to do, plugging in a -3 there or plugging in a -3 and doing that? As soon as you get your remainder, you know you got the answer. This was raising things of powers, getting big numbers. This is adding and multiplying small numbers, usually small numbers, and you came out with the answer. That's pretty easy, isn't it? So sure enough, it worked in that problem. This is now saying that it works in every problem. If a polynomial f of x is divided by x minus k, in other words, you put a k and plug in the k here for the x, you get the remainder. Amazing. The remainder theorem tells you that synthetic division can be used to evaluate a polynomial function, especially if it's a big, long polynomial function with huge powers, and just a little number into that raised to big powers can produce some really big numbers. So if you want to do it this way, usually it keeps it simple, okay? That is to evaluate polynomial function f of x when x equal k. Remember, that's exactly the same as saying this is your divisor. If this was wound up being, okay, now here's the thing. It's not really a factor if you got a remainder, right? So it's not really a factor, but you treat it like it's a factor, say x equal k, okay? And then you do that, divide f of x by x minus k. In other words, take the k part, go into your synthetic division, the remainder will be f of k. Okay, let's do example 5 and see what we get. Okay? It says use the remainder theorem to evaluate f of x equal 3x cubed plus 8x squared plus 5x minus 7 when x equals -2. Now that's not hard to do, but let's do it using synthetic division. What do we put outside the house? -2. When it's written as a factor, you write the opposite. When it's written as an equal, you write whatever that number is. That's a -2. What goes inside the house? 3, 8, 5, -7. Do we have enough terms there? Yes. This is max and exponent 3. We've got 4 terms. We're good to go. Then you do what? Skip a line, draw a line. You forget the important step there. Okay. Then bring down the 3. And then what? It's -6. 2. -4. 1. -2. -9. Okay? I think f of -2 is -9. Okay? Now that was pretty easy to get, wasn't it? Let's do it this way. F of -2 would be 3 times -2 cubed plus 8 times -2 squared plus 5 times -2 minus 7. Okay, let's evaluate that. What is -2 cubed? -8. Times 3 is? -24. See, you're already making it. No, I'm just kidding. Okay, -24. Okay, plus -2 squared is? 4 times 8 is? 32, so plus 32. Okay, and then, this is really ugly writing here, -5 times, or plus 5 times -2 is? -10, right? And then -7. Okay? You only got one negative here, or one positive here. Add the negatives, that would be 34 and 7 will be -41. So -41 plus 32 is -9. Look at that. Look at that. Now, which was easier? About 50-50, maybe. The numbers were certainly bigger here. These are pretty simple numbers here. And multiply, add, multiply, add. I didn't have to remember when a square negative number, it comes out positive, and you raise it to the third power, it comes out. I don't have to remember any of that. I just do the math. Okay? That's the fun part, isn't it? Okay. And sure enough, it comes out negative 9. Okay. That was example 5. There is a checkpoint. Please do the checkpoints, and if you have trouble with them, there's audio video solutions at larsonprecalculus.com. Free website. Anyone can use it. You don't even have to buy a book. Okay. So, we did it. Let's let them do it. Okay. Using synthetic division, put the -2 outside the house and put the coefficients in the right order. Make sure you got enough of them inside the house, and there we have it. Skip a line, draw a line, bring down to 3. -2 times 3 is -6. 8 minus 6 is 2. -2 times 2 is -4. 5 minus 4 is 1. -2 times 1 is -2. -7 minus 2 is -9. Okay? And that's the remainder, and that is f of -2. And we've already shown that to be true. Now, I'm not saying this will always produce small numbers. It won't. You're going to get a big number sometime. Of course you will. But guess what? I'll get them here too if it's the same answer. Only you'll have a bunch of them here. Bigger numbers more than likely. So I found it easier. Okay, I think what they're going to do is plug that in. Well, we can conclude this, or they're going to check it. This means that -9 is a point on the graph of F. Hey, we have another way of getting points, don't we? Yeah, rather than having to plug in a big, hairy-looking polynomial, just do synthetic division on it with the x value, and what you get out is the remainder is your y value. Okay? So they are going to check it here. I think we've already done that, so let's just watch if they get it right. F of -2 is 3 times -2 cubed plus 8 times -2 squared plus 5 times -2 minus 7, and that becomes 3 times -8 plus 8 times 4 minus 10 minus 7, and that becomes -24 plus 32 minus 10 minus 7, and that's -9. Sure is, isn't it? Okay, any question? Okay. Now, another important theorem here is the factor theorem, which is stated below, and guess what? We're actually going to use this maybe as much or more than the remainder theorem. Polynomial f has a factor x minus k if and only if, and we've hit this before, f of k is equal to 0. Okay? Why? Because when is this a factor? When your remainder is equal to 0. Okay? So if that remainder is equal to 0 from the remainder theorem, then you know this has to be a factor. Okay? Using the factor theorem, you can test whether a polynomial x minus k has a factor by evaluating the polynomial x equal k. If the result is 0, x equal k is a factor. So guess what? Synthetic division will do this for us easily too. Okay? We're going to use that a lot. Because what is it? Let's go back, if you can think of it mentally, to the end of 2.2. Somewhere there it said, maybe it's the middle of 2.2. Okay. When we were talking about, I can't find it right now. Oh, here it is. I think it's on page 127. Finding the zeros of a polynomial function is an important problem in algebra. There is a strong interplay, blah, blah, blah. So that's why we're getting this stuff. More tools in our belt to find those zeros more easily. The remainder theorem will tell you, and the factor theorem will help you find others. Okay. So, let's do example 6. Okay? And I forgot to bring my watch in, so y'all going to have to let me know. Don't let me go. I know y'all want to keep going forever, but there is another class coming in here, so please let me know when it's time, okay? I forgot to bring my watch. Okay. Now, Second? What we got? Okay, we got plenty. Okay. Show that x minus 2 and x plus 3 are factors of this. Can you look at that and tell? Can you look at this and say, oh yeah, this factor is x minus 2 times x minus 3 times something else? I can't. Okay. Not in my tool chest. Okay. I can't find that. Then find the remaining factors. So what's the easy way to find out if that's a factor? Oh, we could do long division, do this into that, and see if we get a remainder of 0. Oh, let's not, because we can use synthetic division. So let's do it. Okay, what goes at 2? That goes outside the house. What goes inside the house? 2, 7, negative 4, negative 27, and negative 18. Do we have enough terms there? 5, yep. 4, yep. Works. Then you skip a line, draw a line. 2, 4, 11. Ooh, this is getting big, isn't it? Okay. 18. Ooh. 36. I think it's a negative 9. Oh, no, positive 9. Oh, look at there. 0. Ding, ding, ding. That is a factor. Okay. Now, here's a little trick, folks, but it works. It's not just a trick. It actually works. If this is a factor of that, and this is a factor of that, which we don't know, we're trying to show it, this will also be a factor of that. Because we haven't messed with that into it, so we can use the quotient here and see if x plus 3 will go into that. Well, just like it's written here. Once you got a 0 there, you can do that. If you got a number other than 0, you can't do it. Okay, but if you get a 0, you can. So what goes outside the house here? We build a new house. Negative 3, perfect. And then you do what? Skip a line, draw a line. You always forget the important step. Sorry. I think pollen's in the air. Okay, guess what? Bring down the 2. Negative 6. Oh, yeah, okay. Times negative 3 is 5. Negative 15. 3. Negative 9. 0. Ding, ding, ding. We got another winner. Okay, right there. X plus 3 is also a factor. Okay? That's all they gave us. Now to say find remaining factors. How can we do that? It's fun if they give us the factors, but they didn't. Well, second. Oh, don't tell me that. What does this represent? The first time you did it, it reduced it to a cubic. You did it again, it reduces that to a quadratic. And what can we do? So you got it. Okay. So this represents 2x squared plus 5x plus 3. And then we see if we can factor. And even if we can't factor, quadratic formula. So once we get a quadratic form, don't mess with synthetic division anymore. Either factor or use the quadratic formula. It's there for you. Now, what's the only possible factorization of 2x squared? 2x times x, okay? And then we look at the sign of the last term, which is plus. And what does that tell you about these two signs? They have to be the same, and since that's a plus, they both have to be pluses, okay? Now, what's the only factorization of 3? Say again? 3 and 1. Let's do it in that order. We don't know if that's right or not. Let's see if it is. 2x times x is 2x squared. That checks. And then you do the outer plus 2x, and you do the inner plus 3x. Guess what that adds to? 5x. Good for you. And then you do the last plus 3 plus 3. Yes, those are the remaining factors. 2x plus 3 times x plus 1. Okay. Good deal, folks. Okay. We can now factor a big old hairy looking thing like that if they give us the first two factors. No. We're going to learn to find the factors on our own. They gave us these two, but we'll learn to find them. Okay? So there's example 6. Do I have time to see how they did it? Okay, yeah, we got time. Oh, plenty of time. All right. So use synthetic division on the first one, put 2 on the outside, and put our coefficients on the inside. 2, 7, minus 4, minus 27, minus 18. Boy, I hate these numbers, but they worked out okay, didn't they? Skip a line, draw a line, bring down to 2. 2 times 2 is 4. 7 and 4 is 11. 2 times 11 is 22. Minus 4 plus 22 is positive 18. 2 times 18 is 36. Minus 27 plus 36 is positive 9. 2 times 9 is 18. Minus 18 is 0. Yes. Okay. We have a remainder of 0. Whoa. So I like to block that off. Okay. Now using that, it's a polynomial, a third degree polynomial. We now do our x plus 3 into that, which is dividing the minus 3 into those coefficients we had left over. And what do we have? Skip a line, draw a line, bring down the 2. Negative 3 times 2, negative 6, plus 11, 5, times negative 3 is minus 15, plus 18 is 3, times negative 3 is minus 9. There's another 0, just what we were looking for. And then this represents, that quotient represents 2x squared plus 5x plus 3. All right? Now, because that's a quadratic, we can see if we can factor. Okay? And sure enough, we can. So we now know the complete factorization of that big old, long, ugly-looking fourth degree polynomial is x minus 2 times x plus 3, thank you for giving us those, times 2x plus 3 times x plus 1. That's the complete factorization. That big old polynomial we didn't have a chance of factoring before. Of course, they gave us 2. Okay. But we figured it out from there. Make sense? Nice tool to have in your tool belt, right? Synthetic division. Oh, no, don't tell me that's the end. Oh, there's a checkpoint after that example. And then there's a summary. Have we got time to do the vocabulary? Okay, let's do it. 2 forms of division algorithms are shown below. Boy, that's a real good question, isn't it? You just read them. Okay, so I'll let you read them. Number 2, fill in the blank. Oh, wait, I'm sorry. Identify and label each term or function. What does f of x stand for in both of those? The dividend. What does d of x stand for? Divisor. What does q of x stand for? Quotient. And what does r of x stand for? Remainder. Got it for both of those. Okay, number 2. In the division algorithm, either one of those above, the rational expression, this is the second one, r of x over d of x is blank, because the degree of r of x has to be less than the degree of d of x. Proper, because it's less than, okay? In the division algorithm, the rational expression f of x is divided by d of x is blank, because the degree of f of x has to be greater than or equal to the degree of d of x. Improper. Perfect. Number 4. A shortcut for long division of polynomials is blank blank, synthetic division in which the divisor must be of the form x minus k, coefficient of 1, exponent of 1. Number 5. The blank theorem states that a polynomial f has a factor x minus k if and only if f of k is equal to 0. Factor theorem, perfect. Has a factor theorem. Got it. Number 6. The blank theorem states that if a polynomial f of x is divided by x minus k, then the remainder is r is equal to f of k. Remainder theorem, you got it. Homework exercises here. Do number 7 is at calcchat.com, also in the back of the book. Number 9 is at calcchat.com. Any of the odds 11 through 23. They're all at CalcChat. At 19 is at CalcView. Do any of the odds 25 through 43, they're all at Calc Chat, 27 is at Calc View. Do any of the odds 45 to 49, they're all at Calc Chat. Do either 51 or 53 or both, they're both at Calc Chat, 51's at Calc View. Do any of the odds 55 to 61, they're all at Calc Chat. Do any of the odds 63 to 69, they're all at Calc Chat. 63 is at Calc View. Do any of the odds 71 to 75, they're all at Calc Chat. Either 77 or 79 or both, they're both at Calc Chat. Then some word type problems, applied problems, 81. Do 81, it should be at Calc Chat. There's a true false, 83 and or 85, they should both be at Calc Chat. And you can think about doing 87 if you'd like, and you could think about 89. It's an error analysis I really don't care for too much, but see if you can figure out what the problem is. And then there you can explore doing 91 if you'd like, and you can think about doing 93 if you'd like. Now, let me say this about 2.4. It's dealing with complex numbers. Because you'll probably run into complex numbers in the future, we're going to do it, but we're just going to go through it with a slideshow. I'll talk about it some, but we're not going to do any exercises, because if you go back to the syllabus, nothing in the syllabus said anything about complex numbers. But because it's here, I want to expose you to this, and the secondary feature is later there will be some examples that will have answers to complex numbers, so you'll know what they're talking about. But I'll try not to give you any on the test because that wasn't in the course description, okay? But I want you to be exposed to it. So 2.4 will go pretty quickly, and we'll hopefully get into 2.5 next time, okay? And what's more, because y'all have been so good, I have a quiz for you. We finished 2.3, and that's time for the quiz. And besides that, I just want you to have nothing to do over your spring break. You know, if you have to put up with no math at all in spring for a whole week, well, that would make you so depressed. Okay. So here. Oh, I didn't have it. Do you need graph paper? Yeah, do you need it? Okay. Do you need graph paper? Do you need graph paper? Do you need graph paper? Okay. Do you need graph paper? Do you graph paper? Okay. Do you graph paper? Sure. Yes. I just have mail lately. You need graphic?
Thank you.
Does anyone need to leave right now? I'll get you on the way out. Need graph paper? Need graph paper? Need graph paper? Need graph paper? Anyone else?
You know what? This might be
only get one quiz now. You got that?
He said, oh, I thought we were in the right here.
Of course we have fast food. Are you kidding me? Okay.
Always telling you if it's going up, which way, how many shifts on stuff like that.
Tell them you're not going to leave you at home, all right? Okay. I was just warning you about spring break. That's all it is. Just a warning.
She was like, that's what I was doing. Oh!